This is the last page of the note-taking guide for 1.5 in Math 3. Yesterday we showed you how to factor. We talked to you how to take the greatest common factor out first. And then we also showed you how to factor when there's a number out in front. And we use the box method. Today we're going to do some practice of multiplying here so we can see what happens with some of these special patterns. These are called difference of square patterns because one of them is minus and one of them is plus, but it's exactly the same numbers. Now if you notice when we FOIL this out, you get x squared plus 6x, and then right here gives you minus 6x, and then minus 36. So those middle terms right here cancel. They cancel because it's a difference of squares. And what you're left with is this difference of squares, x squared minus 36. The same thing's going to happen here because one of them is positive and one of them is negative. When we multiply that out, the two middle terms are going to cancel. So I know that I can look at the first term and square it, and look at the last term and square it. 1 times 1 is 1. And then I'm going to keep the sign in the middle negative because that's the only way I can get a negative number. Positive times a negative has to be a negative, so it's going to be back there as a negative. Same thing here. I could take the time to multiply this out, but I know the middle terms are going to cancel. So the first times the first is 4x squared. The last times the last is negative 25. The two middle terms would have been negative 10x and positive 10x, but they cancel each other out, so they don't need to be there. Again, the same thing. This is a difference of squares. You can tell because they're exactly the same besides the sign in between. So you square the first to get a squared, you square the last to get b squared, and the sign in between has to be minus. If you guys memorize this pattern, it's going to save you a lot of heartache over the next few months, so please try to memorize that pattern. So just a reminder of what perfect squares are. So is 36y squared a perfect square? It is, because 36 square roots to 6, and y times y is y squared. 9x squared is a perfect square because 9 square roots to 3, and x squared is x times x, so two perfect numbers there. 16x to the fourth is a perfect square because you can do 4x squared times 4x squared, and that will give you 16x to the fourth. 25m squared is perfect. You would get 5m as its square rooted term. 4y squared is perfect because its square root is 2y. 12, not a perfect square number, so that one's not going to be circled. 24 is not a perfect square number, so that can't be circled. But 100x to the fourth, that one is a perfect square. It square roots to 10x squared. So 10x squared times 10x squared would give me 100x to the fourth. And then the 48 is not a perfect square. Even though the variable is, it's not going to be considered a perfect square because of that. This next problem asks me to factor and solve this. So what I'm going to do is I'm going to look at it. I can see that it's a difference of squares because I can see that 9x squared is a perfect square. Its perfect square or square root is 3x. I can see that 4 is a perfect square. Its square root is 2. And then I know in order to have those middle terms cancel, I have to have one of them positive and one of them negative. Same thing on this one. I'm looking for a perfect square in both numbers there. 4x squared is a perfect square. It square roots to 2x. 7 is the square root of 49. And then in order to get those two terms to cancel in the middle, one of them has to be negative and one of them has to be positive. Two last examples of this. Same thing going on here though. On that 64x squared and 81, they're both perfect square numbers. The 64 square roots to 8x, so I'm going to put 8x in the front. The 81 square roots to 9, and again to get those middle terms to cancel, one has to be positive and one has to be negative. Good luck on your homework, you guys.